All right, good morning. I want to talk about those multiple choice things that you have. On your schedule, there's a thing called multiple choice break. And what that is, and I hope that you don't feel like, wow, I have a 5-day weekend and I'm completely shutting it down. Because if you look, when we get it back, we have minimal days left. So one of the things that we are going to be asking you, I'm going to ask you to do is truly about 15 minutes of actual time, but I hope that we're going to do more than that, where you are going to have to practice a little bit of some multiple choice questions. So how it's going to work is, if you want to just look at any one of them, it doesn't really matter. You have to write the date that you took it. It tells you how long you get. I'm technically taking time away. You get about a minute and 20 seconds-ish. Well, it's only 4 questions. And I categorized it based on chapters. So I'm trying to get us thinking about what we're doing. So if you want to review that material first, and then you take it, that's great. After you're done, in a controlled setting, and your parents will be getting an email today explaining how this all works, you need to have a parent sign this. All you need to do then, and I hope I can make this work on Canvas, is that you need to take a picture of the top. So get your name on there or something else, take the date taken and with their signature. So let me be able to see the chapter. At least I don't need to see the whole sheet, but I should be able to see what chapter it is in the signature. And you upload it to that column. So it'll be like chapter 4 multiple choice, chapter 5 multiple choice, chapter 6 multiple choice. And then after that, hopefully the module will work where there'll be a short little video with an explanation from me of why all the answers are what they are. After you turn it in. I'm hoping that's the way it works. So then you can see. So hopefully you're writing work down on the sides, no calculator. And at some point, if you're like, I'm gonna find a way or get all the answers from someone, that's not the point of any of this. That I'm not grading you based on results. You can get 0 out of 4 as long as you submit it and you try. If you're like, oh, I'm just gonna fake it and then get the answers and make it all look good. Again, that's at some point there's got to be an intrinsic drive. So then you can watch the videos. All of these are due by the time you come back. If you add up the time, it's not that much time. It's not that much time putting in. I didn't count it up. I think it's like 15 total minutes. I don't know. You can add it up yourself. Maybe it's 17. Ashley, question?
Wait, so we won't know the score until like after we watch the videos, right?
Yeah, you'll be able to grade it. So taking a picture, I don't care about the score in the picture.
Okay.
I care that the parent signed it
Okay.
and said, yeah, you did it. That's all. Okay? And then you can grade it yourself, and then you can see, I'm going to talk you through how you get that answer and why. And that should really help. And we're going to do this throughout. We're going to do one per chapter. It'll be really helpful. I've never done it before. As I told you, multiple choice is usually the weaker part of my game on my side of things. I've noticed the scores over the years. My students always do poorly on the multiple choice in comparison to the free response. They still get 70% passing. So if I can get the multiple choice going up, no one other group's ever been able to, or I've never given this extra stuff for multiple choice, and I think it needs to be done. I know Bayport does like 20 to 25 minutes. They don't do a lot of free response. They just work on multiple choice all the time. But they do it a lot in class and just sit on the computers and do multiple choice again and again and again. I do believe that the free response and the chemistry itself is going to be helpful in the long run in everything. So anyway, if you have additional questions for that, let me know. Lastly, I'm going to send out an email. If you have time today, and I do apologize for this, just the train just keeps going and can never stop, and I know you guys know that feeling. I have work in the back, and I will have a description of how you want to do this. By the by the ending of next week, actually by Thursday, I'll say, if you have your stuff organized the way that I'll send it to you by like 6th mod today, of how if you want to reorganize things with all the work, you can get some extra credit as a bonus. So if you're like, well, I don't have time to get all my old work done, that doesn't mean you can't start getting everything organized, right? That doesn't mean you can't get the reference sheets, the chapters all starting to be organized. You do have some work. You have all this first semester stuff, unless if you chose not to pick it up last semester. If you didn't, I still have it. Otherwise, if I will leave my door open, you can always sneak in here and find some of your stuff as well. But you could easily just supplement and put that in there, and that will be for next week. Mason, did you have a question?
No.
Okay. So I will send something about that. And that's something new I haven't done either, so that's something that just kind of got bumped to the back. So that's that. We got to get through a couple problems today. I do want to do finish our test too. No?
What day was that? Organization?
I will send that all, probably by next Thursday.
How do you like show you?
You physically have to show me.
Like, I was
We're-
in
I will, in general, I will be able to see if it's organized or not. I mean, it won't be like you can put like a real $100 bill on the outside and then Monopoly money, and then I'm like, oh, good, that looks like a good, nice wad of organization. Like, I'll be able to know if you've done it or not. Okay. So. Okay, let's go to your chapter 8. Here we go. I believe the bonding one. So let's talk about how this all works. It says, use the information in the table below to respond to the statements and questions that follow. Your answer should be in terms of principles of molecular structure and intermolecular forces, even though that's not from this chapter. So, A, draw the complete Lewis electron dot diagram for ethyne in the appropriate cell in the table above. Now, usually when they say electron dot diagram, if there are extra dots, like on outer atoms, you need to include them. I have seen many, many times where the grading says -1 for not using all the dots. This is a unique one, though. Well, not unique, but it won't matter as much. So let's talk about this. Right now already, I will tell you anything that comes up to organic, and I know we haven't reviewed it, you have had more experience than I will say probably just about anybody that's going to take this test. We do more than most. Most people get a little handout and said, hey, this is what organic compounds look like, and here's the relationship with the numbers, and that's it. They don't really focus on it. I think it's important. I think things come in to play. You just have a better understanding in general. Okay, so every time I go to a conference, people spend like a day on Orgo. We did a whole chapter. So I feel very good about that, though. So if I have to draw the complete Lewis electron dot diagram for ethyne, right here, what is ethyne? What's the point of that? What's yne? Do you remember? Triple bond. And if you don't remember, carbons always bond 4. So if you look at it and you just bond everything, suggestion, bond everything once. And you can put this right in the box because it does actually say put it in the box. Or you can write A on the side as well and do it again. Everything bonds once, for sure. So if you ever get stuck, bond everything once and then start thinking about things like hydrogens only bond once, right? So then the rest of the bonds, I need to make carbon bond 3 times, done. Now, they also have this. I don't like this look, although I had to do this a lot in my chem classes. It makes me very uncomfortable because dots can get lost a lot of times, but either one will work technically, but bond line. So don't ever feel like, wow, wait, they said electron dot diagram, and then start doubting yourself and changing all the rules that you've learned about. Be like, well, can I use lines? Of course you can. Just on a flip side, because I want to make sure you're understanding what I mean by dots, though, like if you ever had to do this. If you had a problem like that, this is what, and I'm not going to do the whole thing. If you put CLs all around, and that's it, you would lose 1 point. It would have to have the dots. You understand? Like it would have to have all the dots. To make sure that you have 8, except for like AL and B, because those only get 3. And then hydrogen. Okay? But that's just a point. So that's just 1 point. All right, let's move on. B, which of the 4 molecules contains the shortest carbon-to-carbon bond? Explain. So which one? The ethyne, because triple bonds have the shortest amount of bonds. Every time you add a bond, you have a shorter bond. You don't need to go into more detail than that. I always feel like I did. I'm like, well, when you have more electrons, the electrons are going to pull in the nucleus of each atom, and it's going to get closer and closer and tighter and tighter. Let me read you what exactly they wrote. Ethyne, which contains a triple bond, has the shortest C to C bond. The other molecules have single C to C bonds, and triple bonds are shorter than single bonds. Honestly, there's no actual explanation. Like, it's not like an actual, like, this is why a triple bond is shorter than a single bond or double bond. But no, single to double to triple. That's decreasing in length, okay? So it should be the ethyne, right, because it has triple bonds. Triple bonds, and you should just say triple bonds or shorter bonds. than like a single or a double. Okay? So, check it out. I am amazed by this, but 1 point here, 1 point there. I know. I would not have guessed that. That's a 1 pointer for me. But that's okay. Letter C, a Lewis electron dot diagram of a molecule of ethanoic acid is given below. The carbon atoms in the molecule are labeled X and Y respectively. Identify the geometry of the arrangements of atoms bonded to each of the following: carbon X and carbon Y. So let's look at carbon X. It's right here. What is the molecular geometry? Trigonoplanar, because it has 3 clouds, right? Does it say explain? No, it doesn't. So that, and write it to the side, right? Like a C sub I or something like that. But this is trigonal planar. If you don't see that, there's one. I'll draw it on mine. 1, 2, 3. There's 3 clouds, and you may want to make a little note on the side for you. Like, hey, 3 clouds. Carbon Y has how many clouds? 4. So the shape would be tetrahedral. I don't know if I even want to read you what they wrote. Now that I say that, I know you want to know.
Yeah.
Distorted tetrahedral,
What? Oh.
because it's not all even. Tetrahedral, or, I don't agree with this, trigonal pyramidal.
What?
Don't listen to that one. Don't listen.
Why didn't he
They're just making up new stuff. I don't even know. C. Energy is required to boil ethanol. Okay, here we go. First time this has come up. I will comment on this after. Energy is required to boil ethanol. Consider the statement. What I'd like to do, if you're already reading it, stop. I want you to take the yes or no or the true or false, the first instinctual answer that you have when you hear this, okay? Like immediately just, oh, that's true, but that's false, okay? As ethanol boils, energy goes into breaking CC bonds, CH bonds, CO bonds, and OH bonds. Is the statement true or false? Justify your answer. Again, the statement, as ethanol boils, energy goes into breaking CC bonds, CH bonds, CO bonds, and OH bonds. Is the statement true or false? What I have found, what year is this, 2010? Since 2010, this is actually the first time. The true-false questions, almost every one of them, and don't go by just this, but almost every one of them, the first thought you get is usually the wrong one. So what you need to do, and they do this now, and I like the true-false questions, you learn a lot from them, but unfortunately when you're on the test, you're not there to learn anymore, you're there to show what you know. They're trying to trick you. That's how I feel about them. Maybe I'm totally wrong and the test takers might disagree. But maybe I feel like they're trying to trick you. So, ethanol boils. It says energy goes into breaking the CC, CH, CO bonds, OH bonds. I'm not saying it's true or false yet, but let's talk about this. Underline ethanol boils and then underline breaking, because that's what it's all about, right? Are we breaking the bonds? What is boiling in general? It's a phase change, right? This is a phase change. So explain to me, when I'm holding these 2 water molecules and I boil them, what's happening? Am I breaking them apart or should I rip these apart? Should I separate these 2 or should I actually rip them apart? I just separate them. I did not overcome an OH bond. I overcame. Reread the statement before the problem even started. What am I answering all questions in terms of? Intermolecular forces. You got to bring that back. You are overcoming intermolecular forces. Ripping this apart is an intra. You are not actually breaking these apart. If you're breaking these apart, it's not water anymore. That's not ethanol anymore. So you're not actually breaking those bonds, right? You're overcoming attractive forces. So this is false. And I bet almost every one of you, if you didn't say it out loud, probably said true immediately, because it sounds true. It totally does. And every one that we run into so far, when I've done it, I said true. I read it really fast. I'm true, totally. I'm like, wait a minute. And then the next time I did a true false, I got it wrong again, and then I got it wrong again. Because I did it really fast, and I'm starting to notice a trend that usually you got to really slow down on these. It is not a quick answer. It's not like when it's cold you wear a jacket, true or false. Like, it's not that direct. It's false. You're overcoming IMFs, not breaking bonds. Let me read what they actually said. Statement is false. All the bonds described are intramolecular. These bonds are not broken during vaporization. When ethanol boils, the added energy overcomes intermolecular, not intramolecular forces. The positive of all this, it is 1 point. It's not like, oh my gosh, it's worth 5. This is my future. Like, it's 1. But just, you'll notice the next time it comes up too, you'll be like, oh, dang it. I really feel strongly about this. I need to rethink everything. I need to change my religion. Everything I know about it is different. E, identify a compound from the table above that is nonpolar. Justify your answer. You got a couple, I think you got 2 options. Give me both. Ethane and ethine, right? Right, either one. Now, this is the hard part. It doesn't ask for both. And right on the side. You need to be able to describe polar and nonpolar, and people have a hard time with it. The answer is never there's a lone pair, there isn't a lone pair. It's about being even or symmetrical or canceling out dipoles. All the dipoles cancel. That's always the easiest thing to say for me. Whenever I see all these answers, all the dipoles would be canceled because it's symmetrical, or something like that. I'll read exactly what it says. The ethane, I haven't read it yet today. The ethane or ethine molecule is nonpolar because all the bond dipoles in the molecule cancel. Or because of the end molecule is symmetrical. Note, explanation must refer to the shape of the molecule. Statements such as all hydrocarbons are nonpolar, the carbon, that was one, or the carbons are surrounded by hydrogens, or there are no lone pairs, do not earn points. They will destroy your case if you ever say about lone pairs. Even this. If you say this one, why is this polar? Oh, because it's a lone pair. It's because it's asymmetrical and the dipoles contribute to one side or another for a charge, or the dipoles do not cancel. That would be the answer. Never about the. You can say the lone pair causes there to be an asymmetrical shape, which causes the dipoles not to cancel out. But if you just say because of the lone pairs, you will be done. It'll be done. It's just 1 point. We're going a little slow. We got to get to this other stuff today. Last one, quickly. F. Ethanol is completely soluble in water, whereas ethanethiol, I probably didn't pronounce it right, is limited solubility in water. Account for the difference in solubilities between the 2 compounds in terms of intermolecular forces. So first, if you're like, I don't know what to do, you have to just look at the 2 compounds. So it's saying this one versus this one, right? And I think I got that right. So what is the item, and they drew it to you. What is, you got to just look at the difference. Be smart. Those are my 2 differences, right? Well, what's OH? It says in terms of intermolecular forces. OH are hydrogen bonds, right? Hydrogen bonds are extremely polar, right? Extremely, like a real strong dipole. So they're going to be attracted. This is important. You should write this down in this. When you are soluble, what do you have to interact with? Water. So you will be extremely attracted to the water. You have to talk about that because that's the whole point. You have high interactions with the water. That's why you're soluble. If you're insoluble, you don't interact with water. It's like you're not very social. That means you don't interact with people. So that OH is going to be real high dipole, which causes there to be a high interaction with the water versus the SH. I'll read exactly what they have. Again, it's only 1 point. Ethanol is able to form strong hydrogen bonds with water, whereas ethanethiol does not have similar capability. The formation of hydrogen bond increases the attraction between molecules of ethanol and molecules of water, making them more soluble. Note, the answer must clearly focus on the solvent interaction, so the interaction with water. Just the mention of hydrogen bonding does not earn the point, so you need to say something like it interacts with water. When you are soluble, it has to actually interact. Look at my prop. It has to interact with the greatest water in the world. Question? So, are you missing part of the Go.
So, do more, is it the more polar is the better reaction?
Yes, because water's so polar. Yep. So you have that interaction. Great. All right, that's it for that one. Okay, so that's just a point as well. I didn't write anything on there, but hopefully you did. I hope you did. Okay, we got to transition because I got to get through this yet, and we'll see how far we get because we got to do our tests. We got to finish those today. Okay. All right. So let's get to 12. You can keep in mind the first time through, I'm just giving you a little bit of kick in the memory, kind of spur some things back. And then your job is to work on the other one, and believe me, through the reviews and other things we'll be working on this morning. So, kinetics. A student performed an experiment to investigate the decomposition of sodium thiosulfate in acidic solution as represented in the equation above. In each trial, the student mixed a different concentration of sodium thiosulfate with hydrochloric acid at constant temperature and determined the rate of disappearance. Data from 5 trials are given below on the table on the left and are plotted on the graph on the right. To be honest, kinetic problems are not as hard as they sound, because you have your orange sheets, which they won't be orange. Don't let that freak you out. I need orange. And you just have to utilize them the right way. So you're given a table. There's concentrations and initial disappearance. So as it's disappearing, the rate is getting greater and greater, and the initial concentration is going down because the rate is increasing. And you can see that graph on the right. A, identify the independent variable in the experiment. All right, the independent variable. That means it doesn't depend on anything, so you don't want to pick up the other 4 sheets there?
Well, I might have one of the 4 sheets. I don't know. I just got it home.
Interesting. Independent does not mean it depends on something else. It's amazing. You do all this really complicated stuff at the ending of an AP year, and you're like, I feel like I learned this in middle school, and I don't know the answer. Dependent means like, I alter the light source, and because of that, my plant grew higher, taller, or shorter because of the light source. Well, it's the height is dependent on my light. It's dependent. You are dependent probably a little bit on your parents right now. You're not an independent yet, and that's okay. Believe me, you all want to be one, and then the minute you are, you're like, oh, that was really good. Yeah, I know you're not there yet. Just trust me. It will happen one day. You'll never admit it to them, but it will happen. So, what is the one we're controlling is what I'm trying to tell you. What are you controlling? What are you able to alter? The concentration of S2O3, right? That's what, exactly. So, we can control it. You might need to make a little extra note. I've seen this come up from time to time. Independent means you're altering it. It's not dependent on anything. You have the ability to move it around. B, determine the order of the reaction with respect to S2O3. Justify your answer by using the information above. Translation, do some calculations. Okay, so how do we figure this out? Okay, this is concentration, if you want to write this down. This is rate. So reminder, order is based on how we alter how much we have versus how the rate of the reaction changed. So all I need to do is take 2 different experiments and divide them over each other and see what the numbers are. Okay? Doesn't really matter which ones. I'm going to pick certain ones because I'm just going to pick 1 and 2 actually. So I'm going to take the concentration over the other concentration. I'd rather have a larger number, so that's 1.5. Why would it have to be first order? It's going up though. And this is not, this says initial rate of disappearance, and this is initial concentration. Good question. Those graphs were time on the bottom and concentration on the left. Okay? It's different. This is an integrated rate law. A differentiated rate law. This is on an integrated rate law right now. And the reason why there's no time. Time is with the graphic calculator. Okay? So this is those other ones, you know, where you had the tables and you had to divide and divide. So if I put the rate over the other rate, I get that. So I increased the concentration by 1.5, and what happened to the rate? It increased by 1.5. Translation, the order is first order. And how do you know that for sure, like technically with the math, is that this would be x, 1.5x for the concentration. So this would have to be first order. Oh, got some change now, that's sweet. What would have to happen if this was second order? It's 1.5 squared, and then it would be that value. And then what if it was zero order? This would be 1.5. What would that be? 1, because the rate never changes. Oh, I quadrupled it. I doubled it. I cut it in half, and the rate's still exactly the same. That'd be zero order. Okay? That got me good. All right. C, determine the value of the rate constant for the reaction, including units in your answer. Show how you arrived at this answer. Reminder. Let's do a generic rate law here. Rate equals this. In this case, it's only one thing. Rate equals that. Like, that's a rate law. If it ever asks for a rate law, now, why did I put x there? In case it was a 1, a 0, or a 2. So, how do I find the rate constant? The only way you can find that, guys, is if you have everything else. Well, all I got to do is take one of the lines and plug them in. So, I'm just going to take a rate, and I'm going to take a concentration. I should have actually... should write down the units here. To show how you arrived at this. Include units. We need to talk about that. So if I do the math on this, I get that. Now, you're going to have to just kind of look at this, but this isn't all that tricky. Look at the units here. This side has to equal the other side. So what would the units be without trying to memorize all this? It is hertz. Fancy man with one side of the glasses. Oh, my temple itches today. I will remove it so I can. It is hertz. You are right. Yeah.
If it says to like give the units or whatever, and you have the right answer but the wrong units, are they gonna mark that wrong?
So let's talk about that. And I forgot to give some other points. So this is always 1. Okay, this is tricky. This is 1 and the work is 1. So always when they ask for a K, ask this question is, what if you give the right answer with the wrong units? Literally, that's how they give the points. Units. All right. D. In another trial, a student mixed 0.1 molar with hydrochloric acid. Calculate the amount of time it would take for the concentration. Okay, to drop to 0.02. Time. This is an integrated rate law. So what's the first order? Concentration, natural log, or inverse? Natural log. Where can I find this? On my equation sheet, right? It should be this. So, let's try to remember this, and this will probably be the last problem we actually do, and if we have time at the end, I definitely will go into the last problem, but I'm sorry. In another trial, the student mixed 0.1, calculate the time it would take for the concentration to drop to 0.02. So where does the 0.1 go? Concentration. On that one? So the 0.02 goes there, right? And what else do I know? I know K because I'm looking for time. So I plug it all in. Okay? They're going to ask at some point that they're going to talk about time. They're like, oh yeah, that's the integrated rate law. That's on my sheet. I just had to plug it in. How did I know I had to use this one? I needed to figure out his first order. So, when you're all said and done, I'm just going to give it to you. 1 point is earned for just setting it up. So did you use the right equation? And then 1 point is earned for the answer. Please make sure that you have the right unit. It's going to be seconds or minutes most likely. It's always seconds until you stop. It is always seconds until you don't look. That's how my experience is. The minute I don't look and I assume it's seconds, then it's minutes. I swear, every time. And I bet that's happened to you. You're like, oh, come on. I did that to you on the test once. And we had that. Finally, E. On the graph above, sketch the line that shows the results that would be expected if the student repeated the 5 trials at a temperature lower than that during the first trials. So if I come back up here, let me reread it again. On the graph above, sketch the line that shows the results that would be expected if the student repeated the 5 trials at a lower temperature than that at during the first set of trials. So you got to look at this. First off, temperature would cause the reaction to speed up or slow down. Slow down, okay, so that means the rate would be less, so the slope should be less steep, okay? So now here's my question. Is it the green or is it the blue? This is why they asked this. What is the y-axis? Read it. This is not a time thing with an amount on the side. This is not an amount. What is the y-axis? It is a rate. So when the temperature is lower, what happens? The rate goes down. So is it green or is it blue? It is blue. This is not this equation graph. We have some sort of a concentration because then you'd start with the same amount. This is a rate. So it would start somewhere lower. It doesn't have to be perfect. Be like, I don't know exactly. It doesn't matter. As long as it's at a lower spot and the slope is less steep. Okay? And that would be 1 point.